We now proceed to the second example, and this is the paradox of Zeno. So here is the problem. A dimensionless frog sits on the end of one-dimensional log of unit length. So this is the frog at the end of the log. Now the frog jumps halfway, and then halfway, and then halfway ad infinitum. The question is, will the frog reaches the other end? So in reality, well, the frog will reach, say this is point A, it will reach point B. It will definitely reach point B. However, on the paradox of Zeno, the frog will jump halfway. So from A to B, halfway is here. The frog will reach this point. And then from this point to B, another halfway. And then from this point to B, another halfway. And then it keeps going halfway ad infinitum. Therefore, in this paradox, the frog will never reach point B. That's the paradox. Okay? So mathematically speaking, this is represented by 1/2 plus 1/4 plus 1/8 plus. This is the infinite series as shown here. So 1/2 is from point A to this point. So that's the 1/2, and then 1/4, and then 1/8, and so on and so forth until you end up with the sequence 1/2 raised to n. So for my example number 2, that's the introduction. So this is now the question. Find the first 5 partial sums and the nth term of the sum of the sequence of this paradox 1/2 raised to n. So let me write the first 5 terms. So if n is 1, that would be 1/2. If n is 2, that would be 1/4. If n is 3, that would be 1/8. If n is 4, 1/16. If n is 5, that would be 1/32, and so on. That's my sequence. Now partial sum, my s sub 1 is 1/2. S sub 2 is the sum of the first 2 terms, 1/2 plus 1/4. And by common denominator, this would be 2/4 plus 1/4. It's now equal to 3/4. S sub 3, the sum of the first 3 terms, 1/2 plus 1/4 plus 1/8. By common denominator, this becomes 1 or 4/8 plus 2/8 plus 1/8, and this is 7/8. S4, the sum of the first 4 terms, I have 1/2 plus 1/4 plus 1/8 plus 1/16. And by common denominator, I have 8/16, that's 1/2. 4/16, that's 1/4. 2/16, that's 1/8. And 1/16. The sum now is 15/16. So if I go to S5, I can definitely see the pattern here, the relationship of the subscript and the sum. So if S subscript is 1, that's the denominator is 2 and the numerator is 1. If subscript is 2, the denominator is 4, numerator is 3. Subscript is 3, denominator is 8, numerator is 7. Subscript is 4, denominator is 16. So I'm showing a pattern that the denominator has a base of 2 raised to the subscript. And then the numerator is just 1 less than the denominator. So meaning if this is my denominator, my numerator should be 1 less. So I'll copy my denominator and then minus 1. So 2 raised to 5 is 32. And then if my denominator is 32, that's minus 1, it should be 31. My nth partial sum now, therefore, is 2 raised to n, and then numerator is 2 raised to n minus 1. All right, so it's implying that if I add this paradox, I have 1/2 plus 1/4 plus 1/8 plus 1/16 plus my nth term is 1/2 raised to n the sum now, the partial sum, is equal now to this value 2 raised to n minus 1 divided by 2 raised to n. Now, how can I convince myself that this equation is true? So let's show now that this equation is true by, of course, mathematical induction. So first step is to prove true for n equals 1. And that would be 1 over 2 raised to 1 is equal to 2 raised to 1 minus 1 over 2 raised to 1. So my left side is 1 over 2, and my right side is 2 minus 1 is 1 over 2, so it's true. First step is done. Second step, assume true for n equals k, so we'll simply assume because this is our basis for step 3. So there you go. All n is replaced by k, and the assumption is done. We shall now go to step 3. Prove true for n equals k plus 1. So we have 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 2k, and then we'll add the next term, which is 1 over 2 k plus 1 is now equal to 2 raised to k minus 1 over 2 raised to k plus what we add on the left side, we also do it on the other side. So that's 1 over 2 raised to k plus 1. We'll simply manipulate the right hand side, so left hand side remains. So in order for this to be simplified, we need to make sure that the denominator is the same. In doing so, I'm going to multiply 1 on this fraction, so I'll be utilizing 2 over 2. That's equivalent to 1, multiplied to 2 raised to k minus 1 over 2 raised to k plus 1 over 2 raised to k plus 1. So let's simplify this part. If we multiply same base, if we have the same base, we simply copy the base and then add the exponent. So let's see what's going to happen. 2 times 2 raised to k, copy the base, then add the exponent, so k plus 1. Then 2 times minus 1 is minus 2. Over 2 times 2 raised to k, so copy the base, and then add the exponent k plus 1 plus 1 over 2k plus 1. My denominator is now the same. I can simply copy my denominator and combine my numerator. So that's denominator 2 raised to k plus 1. They are the same. Copy it and then combine my numerator. That's 2 raised to k plus 1 minus 2 plus 1. And this is the same as 2 raised to k plus 1 minus 1, negative 2 and positive 1, over 2 raised to k plus 1. Note that n is equal now to k plus 1, so I can now replace k plus 1 into n. My left hand side is equal to 2 raised to n minus 1 over 2 raised to n. So therefore, the equation I have created is true, stating that the partial sum 1/2 plus 1/4 plus 1/8 plus ... plus 1 over 2 raised to n is equivalent to the partial sum, which is 2 raised to n minus 1 over 2 raised to n. That's the end of my example. Thank you for watching.